opportunity to come here to Montpellier, beautiful Montpellier, but also to speak to this audience, so very, very different from my field. And possibly of a concept that which you are more familiar than I am. So I come from the field of affective computing, as Julian said, and human-computer interaction. So I wear two hats. Interested in building smart systems in the area of affect, but also interested in understanding people and designing technology that regulate emotion, that steer people into particular emotion. I will introduce briefly this field, even if I saw some of you are working in this area, but I just thought that maybe not everybody is familiar with affective computing. And then I chose one of the projects I've been working for quite a long time to give a sense of these two sides of my work, building systems versus that sense emotion versus systems that affect people emotions. And in the context of physical education. But I start from what is affective computing, so this is not a very beautiful picture myself, but here I was many years ago now testing an app that came out that measure facial expression. And so one of the areas of affective computing is to create a system that automatically sends people emotion or detect cues that may be related to our personal feel. And facial expression is probably the most explored area, and we start to see application coming out in the industry, and of course bringing a lot of ethical issue with it. So at the moment it's quite a hot topic in the bad sense, not only in the good sense. But there are a lot of very good opportunity. Facial expression is not the only one. We are using a lot of sensors that you yourself are using in your field, from taking advantage of the low-cost sensing technology now integrated in our watches, bracelet, phones, or even have a camera now is pretty cheap. And system that measure muscle to infer the movement of your hands. So as you just said, I look a lot at the touch as an affective modality. And also EEG with the full cap, or the more trendy one used for computer games with UV electrodes. So a lot of different way of measuring emotion. The one I explore for longer as introduction is body movement. I've been very much interested in body movement, partially because I like sport, but also because it was less explored the other modality. Despite the literature in psychology shows that it is as powerful, as informative as facial expression. Some studies, like the one from Azuzier, also show that despite we think we are judging, we are evaluating somebody emotional state from their facial expression as we interact with them, we are reading many times their body. We are not aware of that. And there is also a lot of literature showing that sometimes we read much more from the body. And as Beatrice Gelder says, emotion scientist, well known, the body tells you also how you are able to cope with that situation, how you're going to be ready to react even if you're not doing. So you know much more from the body than from the face somehow, and from a perspective of human-computer interaction that is important for me. But I think in many applications, knowing how the person is reacting, what is ready to do, how is coping with that is critical to know how to adapt, for example, therapies and so on. Just to give you an idea of how we express emotions through the body, I'm sure everybody here can see who's just lost the point, who's disappointed by performance with this hunchback and this movement of the arm, and who is confident, large shoulder, large leg, wide open legs, and so on. So this wide body confidence without showing off, but just showing that state of mind. So body is very much expressive. And you can see here, maybe, I don't know, it's quite dark, but these people are wearing motion capture, so where you sensor across your body. And I've been doing, I took advantage at the beginning when I started to look at a study body, the full body technology that was emerging, so you may have played Wii and Kinect games at the time, and also cheaper motion capture system that were moving from a setup lab like a Vicon to be more portable, so I could measure people in a more friendly environment here during a class. So taking advantage of this possibility, so that for me it was critical that I could see real expression. A lot of work on emotional expression recognition was based on active expression. And when we try this system out in the real world, they often don't work because they tend to recognize those stereotypical expression only. And I was interested in understanding the body and the subtleness and the differences between people and also culture and so on. So that was a nice setting, computer games, people emote. But as you see, I studied many other body movement in many other contexts. Using those motion capture systems, we could extract very easily features about the movement. Of course, we can do this also by using camera-based type of sensor and extract very detailed information about how the person is moving. And those details, for example, a slight bending of the shoulder could be very informative about a change in emotional state, or slight bend of the trunk, but also all the parts of the body contributes to read somebody's emotional state. And of course, the dynamic feature, again, using this type of sensor, become easier just to concentrate on the state of the body and leaving computer vision issue aside, as we were trying to understand the body and we're trying to understand the building system that read those information from the sensor, and using machine learning algorithms try to learn to recognize those emotions, going beyond the idiosyncrasy of each person, going beyond the type of activity you may be doing in that moment. That the fact that you're bending is maybe you're taking something from the floor and not because you're down or included. Here is some performances in the context of sport games with computers and many different types of games. So the system was completely agnostic about the type of game performed. And you can see all above chance level, the recognition of 4 emotional states. I'm just giving this as an example rather than just to discuss the performance in itself. But this performance were very similar to the one obtained when looking at emotion recognition from facial expression on naturalistic expression, not active expression. And this performance increases as you put them in a context, so you create that context. And context is critical also for people. If you remove context and compare the result we obtain from this kind of system with the agreement between people in reading emotion, that is a face or that is a body, again we get similar performances. And context really allow us to understand what that expression may mean. Because sometimes we do the same expression with very different meaning in different situations. So quite interesting result from all this modality, and for me, for body has a critical modality in my work. I didn't look at body movement only as a way to recognize emotion and say I have my human-computer interaction act too. I was very much interested in how body movement affect the way you feel and how I can use it to manipulate the way you feel. Here is a video that I show very often in my presentation. And you can see this person, the anger, he's really boxing. He's playing the Wii box really as it was on, and they are fighting against the person. You see the jerkiness, the movement, not only those facial expressions. And here's another person playing the same game. Very, very different. He's playing a game, and he's even somebody who is very expert at this game. The only motion you see is at the end when he makes a mistake, that little tiny movement of the head in the game, this movement down of the arm. We did a lot of study on modifying the way people could play to see if we could, through proprioceptive feedback, through visual feedback, getting people entering different roles and also experience very different type of emotion within the same setting. So very much, and you will understand why I focus on this aspect of understanding how we can design technology that regulate, change, enhance people's emotion. I've worked across many areas, from education, looking at a variety of emotions that we study that were important for learning, like confidence or lack of confidence that can interfere with learning, but also cognitive state. Can we identify cognitive state from the way a person moves? So that we can adapt our virtual game for learning mathematics was the context of this project. We work in cars to detect comfort and adapt the environment. We are working in, starting to work on long distance running with the idea of sharing a richer experience of the runner with the audience. But the focus on my talk will be on rehabilitation. It's a project I've been working for a long time, and it will give you a sense of things we do across this different area of affective computing and interaction. And the context of rehabilitation is chronic pain and collaboration with a clinician from the pain center in London, and also with various disciplines in computing. And it's supported initially by a grant funded by the EPSRC, a UK funding body, and currently by Entitlement, a European project looking at innovating movement tracking technology and also machine learning to understand those qualitative, subjective, affective and cognitive state in people. So chronic pain, rehabilitation. So here when I started, there was a lot of attention to the opportunity that the game were bringing, a full body movement games were bringing to this area. And we see some games here in the demonstration area, how they make physical activity, normal exercise much more fun. And also you get feedback on how you're doing it. And this is now you can do it even with the smartphone. There are applications even dedicated to physical rehabilitation for chronic pain that work with just putting a smartphone 3 meters from you and tracking your movement as you go. And of course, all the other sensing technology we use in sports. And a lot of applications are built in this to target a much simpler activity according to the capability of the person. And then there is an emotional side that if you succeed, whatever you do, you get kudos, you get social support, and you get medals, this kind of reward. This kind of technology is very useful, we see already, that motivates us, but it's not enough. And it's not touching on the emotional aspect, it's touching mainly on the performances. Even the one designed for chronic pain is about pushing people to do more, because physically they can, so they should be doing this. And unfortunately, when you work, and you know better than me, as you come from a more related field like mine to this kind of work, rehabilitation work, and even chronic pain, so I don't think I need to define what chronic pain is to this audience. Patients get very angry when we say we are building technology so that you are more motivated in doing physical activity, it becomes fun and so on. And really patronize it, because you say, I am motivated, but I'm blocked by my fear, I'm blocked by my pain. And also talking to physiotherapists, there is this need to understand this physical, these psychological needs. And we were looking at the type of technology that is creating for rehabilitation, often emotions are missing from there. Here is a quote from a patient, thinking, even if it's not conscious, I'm constantly in fear, very anxious, and this is blocking me for engaging in normal movement that in theory I could do. Our patient didn't have low back pain, chronic back pain, but no injury, no inflammation of tissue, so in theory could perform such movement. So we started to work with patients, with clinicians, with patients that were currently graduated and learned to manage their condition, although that were still struggling, with psychologists, observing a variety of activity they were doing with patients. We went even around London with patients and physiotherapists to understand how they were teaching them skill to self-manage their condition and being able to move, to remain physically active. We looked at gym classes in the hospital. We went in the home of people to look at how they were doing self-directed rehabilitation. So it's been quite a long study where we went through iteration of design. And I'm just showing just one design of that from our work. There are more detailed in our papers. One where really I exploit different multisensory feedback, or well, here showing focus on the sound. But what we were trying to do is what emerged from our study: the importance of creating positive awareness of physical capability, bringing attention to pleasurable sensations that come from our body, never push to do more than what you psychologically feel capable of, and taking control. One of the systems we created is based on sonification. And sonification, again, is not new. It's very much used in rehabilitation and motor learning, and possibly many of you have experience with that. What those sonification often do is correct movement, indicating, for example, rehabilitation, if you are going outside a trajectory that allow you to really take advantage of the exercise from a muscular activity perspective, and so on. So a lot of correction. What we're doing here is to try to address psychological need, fear of movement in this case. And the most successful sonification was the most simple one here, with a sequence of tone, ascending and descending scale of tone that were calibrated by the person itself to the amount of movement they wanted to do. For example, the amount of stretching forward of their trunk. They could select the maximum stretching they wanted to achieve. And after the calibration, the sonification would be adapted to this range with an intermediate point also set by them, and say, up to this amount of stretching, I feel confident doing. After that, I become anxious. And I want to try a little bit. So you may want to understand better here. So now it's calibrating. There is a fold on the back. That is, I don't think the sound is... That's right. So it's you can see some protective behavior here. So now the 3 points have been detected. And
if you could just do that, going up to your mat, most often.
See, and the person is stretching, go up and down to the maximum, and then playing back. I don't know if you can hear the sound.
Yeah, sort of focus more on the noise than I am on the fact that it's sore. Yeah.
So this kind of sonification, so we use many, and you can see here some very good results. You can see all the statistics on the paper. This wave sound was the most informative for them. All other sounds represented here in red and purple were also useful, And all of them were bringing their body out. They were able to attend to their body. They were more aware of what their body could do. Without sound, they felt that the anxiety was coming from the ability of not being aware where their body was and what they were doing. So this gives them control again in the ability to engage in physical activity itself, but really rich information at the same time, very simple type of sound, so that they could quickly attach its meaning in relation to their body. We try many more complex sonification are reported here by working with music computing experts, but the most interesting one was this, despite not being a very aesthetically pleasing type of sound. What was more interesting that emerged from here is that when you go in their home of people, so not a physical rehabilitation session at the hospital, but at home, physical rehabilitation is not exercise. As we know, many people do not perform their set of exercise, some more than others, but many, especially with chronic pain, avoid that. And they say, I don't have the energy for engaging in exercise. If I have some energy, that has to be dedicated to what I need to do. That could be chore in the house, as this photo here represents. And so those chores become the opportunity for them to do stretches or to do other types of exercises. Some, as we call graduate patients, were able even to organize the house in a way that would challenge them just that much they needed. And we might put in things a little bit higher. We see organization within the house having little carpet close to a specific place where a person was struggling for doing the activity, and so they were taking pause and do the exercise on the spot. So rehabilitation became ubiquitous and was not anymore that idea of just computer games or session where you do dedicated exercise, but being really part of your life, and this is their own. The same happened outside, where we were walking to the museum with clinician and patient. The exercise had to be done there. Stopping in the middle of the museum, doing stretching, and we would sit down with there and address also, social environment. So really considering our technology help you to think rehabilitation in this way and making it more effective. So we learn in that and see patients really looking for functioning rather than exercises. They wanted a device at home and try, so we redesigned a way that they had a controller so they could recalibrate it as much as they want very easily. They give them a way to attach it to their body. You can't see here, but there is a pocket on the back of the t-shirt where the person could put the phone and then a controller, like a TV controller, could select the music and select the calibration. And these are examples of diary study that we were receiving periodically for patients using the device in their home and really learning how the device was helping. And this was just a prototype sent there to explore as a research tool rather than a final solution. And there was a lot of serendipitous learning from the patient side as they were calibrating, thinking, I can't do more than that. So they set the target pretty close and then realized that as they were functioning around their home and sometimes forgetting about movement, the sound would finish, meaning that I'm bending much more than I thought I could do. There was a lot of learning of using the device to apply strategies, strategies that were learned at the hospital or they were learning a dedicated session like Pilates, and see if I can do that in the exercise. I can use the device to do the same as I engage in physical activity, in functioning activity, by using this sonification, but then the sonification we are talking about my body sounding. Some people went out as a social work was much more scary on their own, where they don't have control at all, and really exploring and understanding their body outside. And people using it 10 days started to be confident and starting to put the device out and say, I know a little bit more my body. And it was the idea of reusing the device when they need, if chronic pain, you go through bad days and good days, or bad period and good period. So seeing as a device, you can go back and reuse. They use the device in many, many ways as a tool to understand even the environment and reorganizing it in a beneficial way. But what they wanted, it was that a device that would be smarter, would be like a little coach, one of you possibly, on their shoulder, or a physiotherapist there. They help them, especially when they are anxious, to become more aware of what they can do and what is beneficial, avoiding in good days to overdo, because that overdoing, because that meant to be in bed again for weeks. So really learning that right level of activity for them to get better rather than losing capabilities. So understanding when you bend because you have to, or when you even if you are anxious or in pain, or when you bend because you can do it and you can manage that even psychologically. So that was very interesting for us because, okay, we have developed a technology that can provide support, and there are other ways of breathing, there are other interventions we develop, but we can't have this device all the time working. Can the device personalize and really respond to people? So we were working already on detecting emotion from all these signals, but it was very interesting to see how patients themselves were coming out and asking for it and finding very different reasons for using this type of application. As I said, in parallel, so from now I leave this my HCI side of the work where I study people and this interaction with devices to go to the side on which we developed system for recognizing emotion. And as I said, in this talk I mainly look at body and signal related to movement. So we were running in parallel to all the study a data collection that took quite a long time, 2 years to get the data collection with about 60 people between healthy and people with chronic pain. And we use a variety of sensors, including movement sensor, as you can see here, a person wearing a motion capture, and EMG sensor. You can see here as people wear people with low back. So we position this according to the literature and our physiotherapist collaborator, and also on the shoulder, because then in anxiety you tend to contract this upper body. So we collected all this data. At the same time, video that we use with physiotherapists to have them to label all frame by frame all our data, practically using as the video as the mean to attach label to all the sensor data we had. This annotation was based on the literature and chronic pain in terms of protective behavior, like hesitation, guarding, and other type of protective behavior. Together we had many other questionnaires that we were asking at the end of each small exercise in terms of perceived pain, a person, anxiety. We had also standardized questionnaire in relation to general anxiety, depression, and what we have been doing is creating technology that is able to track the status, so track protective behavior, identify when they occur, or also try to predict how a person would, how much pain a person will perceive, and also a general state of low mood and anxiety over more longer term. And here, just for a question of time, I just present just a couple of architecture from machine learning perspective, just showing what we are trying to do with them. Here is a sequence of exercise the patient were asked to do, movement that were selected as a typical movement in everyday life, stretching to pick up something, sit down, and people with chronic pain, which you know very well, tend to avoid. With different level of difficulty, like carrying weights as they were going for shopping, or simple, without prescribing the way they have to do. They have to do the way they would do if they were at home, because the system had to detect their own way of expressing those here. And the healthy participants were here just to bring the idiosyncrasy that people have in moving, so not working on a gold standard trajectory for the performance of each activity. Yeah, we had all our sensors, so you can see here typical activation for a healthy person on the left doing a stretching forward. You can see here instead one from a patient with chronic pain, seeing that even when the person returned to standing position, those muscles are still contracted with the fear of relaxing to feel more pain, or not engaging at all, just using other parts of the body to do a movement or not doing it at all. So going to the machine learning, so one thing we show here is just to give you an idea of how one of the system perform. It's not even the best one at the moment. I just had this video with me. You see the system, when the system recognizes that the protective behavior is occurring, the body will become red. The color of the head is what the real label, the label given by the physiotherapist was. So when the color match the system and the physiotherapist agree, when they are different, possibly our system is making a mistake. But sometimes discussing with them, it could be that the system is also reading the muscle information that a physiotherapist didn't have, was just looking at videos. This is analyzing only the exercise, so there will be gray area where the system is what we call transition is not looking at. So you can see here the system detect protective behavior, but the physio detect the starting a little bit later. Again, it could be for the contraction in the muscle or just some segmentation issue. Here, so the transition is preparing for the next exercise. That is a stand to seat. You can see using the hand and so on. So quite interesting result. Again, what I wanted to point out here is the architecture we've been exploring with an entrainment that I take advantage for, of course, the current networks are allowed to us to deal with temporal information and detecting movement over time, but also using attention mechanisms to try to understand what part of the body may be more relevant to make those decisions. Of course, there is a lot of redundancy. We're not saying that what the network pick up are the most important, but they're the one that the network is finding useful to do that. And here you can see performance of the system, but what is interesting for me is to show this attention score temporally as the person performed the exercise, and also vertically you see the importance of the joint. So darker color means one joint is more important than the other. And we can see that in the healthy, this color don't change that much between joints. So the system is taking advantage of all of the joints in a similar way as the person move their body in a more synergetic way. When we look at this score map for the different patients, we often see something similar to that for any exercise they're doing. So there is this switch from now I'm bending the trunk, then I bend the leg, and possibly the network is picking up this. What we are doing now is to use this network to detect when the person may need support. So when attention understand how the person is psychologically doing with this movement. But we are also using the score from this architecture to think about driving the sonification and also new sonification of the body movement to trigger awareness towards particular part of the body, rather than just using one sensor from the smartphone, as you showed me also before, is taking advantage of a different sensor across the body and triggering attention and exploration of the person on those parts. So we are working on that, and there is some video I can point you on our web. You can look at it, but we haven't yet tested with the patient. Here is the second network that I showed, and on this one, so before you saw there were gray part transition. What we are trying to do now is really continuously tracking, so going through without knowing when an exercise starts, as we want to use it in functional activity. So we don't know what the person is going to do anytime. But we train the system to work on very basic unical movement. They are typically that are the building blocks for brick for any type of movement, and see if we can continuously track that. And so to do this, we have to work by using different approaches from the four. First of all, we see an improvement by using particular machine learning technique, this graphical convolution network, that allow us to input the data in the system in the form of a body, a graphical network that capture directly the relationship between body joints, and also having two different networks that work in parallel. One is called HAR, Human Activity Recognition. So we have the same information coming from the sensor, where we try to predict what is the person doing now, and then we use this information in parallel, continually sent with the sensor data to the protective behavioral detection, the other module, that has a similar structure at the moment, that try to infer if a protective behavior event is occurring, given the knowledge of possibly of the activity that the person is possibly engaged in. And we see much bigger improvement in terms of this continuous detection, rather than having this pre-segmentation activities to do that. It's quite complex when you work in a continuous unknown situation. We have here the result from recognizing the different activities, standing over a leg, reaching forward, sit to stand to sit, bending, or other, for the moment, transition movement that could be walking, or other thing the person was doing just to stretch and relax before doing other exercise. But what is interesting for us is the performance RI that we use activity recognition. We don't use at the top activity recognition, or we use it. The performance seems similar, but when we look at the real result, we see that the system is much better at detecting protective behavior represented by this cell in the confusion matrix. A big problem when we're dealing with this type of data set, where the type of behavior we are interested in is sparse. We are working with very, very unbalanced data set. So this kind of information is important. This network doesn't use EMG at the moment. We have initial result by introducing the EMG2 that increase performances. What is becoming interesting now, how do we fuse those two signals? So we are exploring different ways, some taking into account also the relationship that exists in the body, and other much more straightforward fusion technique. We are also trying to decrease the number of sensors, and looking at can we go down from 22 joints, we're using 17 sensors, to a much smaller network, and study how we can do this, even by looking at techniques that allow to train on larger set of sensors and then reducing. And what we have been doing during COVID time now is sending a sensor in the home of people, and cheaper sensor than the one you saw in our data collection, that work with the phone. And we have taught them to use them by using a remote call, and then we started to collect data as they move around and do activity they have pre-selected in the home. They have to do their own chore or other activity that they like. And I also then left, with some patients, we left the sensor for longer with them so they could continue to collect data. So hopefully we are finished now. We are starting to look at this data, much more complex situation, but the one that reflects the real world. So our initial result we had obtained before with a smaller data set of this type, and EMG was already showing quite good results. So we are very excited to start this analysis. But data is an important need in our I think to briefly go, so I talked initially about using technology to modulate people's emotion, to change people's perception of themselves and what they can do, and then went on how we could combine it with emotion recognition capability so that we can personalize and to the needs of the person. We are also developing many other types of way of altering people's perception of themselves. I wanted just to briefly go into this one. That is a project that we started with Anna Tajadura when she was in my lab, and now we are continuing to a new project funded by the Spanish government, Affective. It's still led by Anna, where we are not altering directly how they, what people think they can do, but altering the perception they have, their body size and body shape. Here we are using shoes. We call them, journalists call them the magic shoes, that have, as you can see, a microphone attached to them. And the idea was, when we hear somebody walking behind us, we can start to say, oh, that's a big guy or a small guy, especially if you're a woman in a dark lane in London, and even in it, pretty scary. So we are very good at predicting a lot from their sound of their footstep about the other person, even the gender. We wanted to see, based on the old neuroscience study that show that the perception of our body is not static, but is continually updated through the feedback we get from our action. If we could see changes, and if we could alter the perception of your own body weight, but alter the perception of the sound. So we had, with the microphone, we were detecting the footstep. In this case, a journalist is walking on the spot, but our people were walking along the long path. And then altering towards lower frequency, typical of heavy body, or higher frequency, typical of a lighter body. And the question? And here the lighter. So they are synchronized with the movement. So we see results here showing that people reported to feel lighter, and we had different measurements for that. They move their foot as they walk, less time of contact with the floor, much more dynamic way of movement. And so a lot of indication showing that people felt much lighter and also capable of movement. We repeated the study, climbing stairs. We see people finding climbing stairs much easier. So we did different studies. So again, you can find a different publication showing the statistics of those. But what we did is to apply to a particular type of chronic pain called complex regional pain syndrome, or CRPS, where people either don't perceive their body, part of their body, or perceive them very large. And so what we did was to try, so using our magic shoes, we could get the body either to reappear or to become smaller, so to be more similar to what their real body was. And with real initial result, we saw that happening. We saw, for example, especially in people that couldn't perceive their body, you can see a drawing of a person of their body before using the shoes and after using the sonification, after the appearance of the leg. Sometimes we see also pain increase, because the fact that the body disappears may be a mechanism to cope with the pain. Here there are some results. The population was very small, but what was interesting is that we observed very different patterns. The sonification was helping. It was less clear between high frequency or low frequency, but there was an effect, especially in people where the part of the body were disappearing, but also in the other, much more difficult on the mixed population. And I conclude here, skipping these two pages. Just trying to give you a flavor of the type of work we are doing across this field, and the possibility that this low-cost type of technology offer in this context. We are also working on a case of people that don't have any condition but just find it very difficult to engage in physical activity, either for social embarrassment or body image or other issue. And this idea of using embodied mechanisms, bottom-up mechanisms, not just reward at the end, bottom-up mechanisms that work in the moment as I have to engage in the activity and not afterwards, to change the perception of myself and increase self-efficacy. Emotion recognition is useful. There are a lot of ethical issues around here. There are a lot of opportunities at the same time with all the sensor we now have anyway on us. I think what my big message for me from the side is that we need to work with real data taken from the real world and not from a lab study as much as possible. Those data are also useful, but if we want to make technology usable, it has to reflect those expressions because they are much more subtle and the variation is much larger than you see in the EASIA's data set collected in the lab. And we need data, so from any community, those are welcome. Thank you.
va poser sa question.
So if you approach emotion as an action mechanism, so the state of expression would be characterized as the absence would be the moment when you try to extract the relevant information. So that this line would expect others, so that you can discriminate with others. Like the question about your perspective for the future, how the different idiosyncratic properties can be or should be incorporated for extracting emotions, pain, for instance.
C'est comme ça. Ouais, mais moi je vais comme ça. Je vais pas faire quelque chose. Qui répète quoi?